Hey everybody, in this video we're going to practice the concept of average rates of change. And every time I teach calculus, I always tell my students, as soon as you hear the term rate, or specifically average rate of change, think slope. And that brings back all those concepts from algebra that we're really going to be using here that really are no different. And it helps in calculus to just think average rate of change, same thing as slope. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. So here we're given this function graph, and number one says we want to find the average rate of change, again, like I said, think slope, from x equals 0 to x equals 3. So if we are finding slope, the expression would be f of 3 minus f of 0. If you were doing this in algebra before you learned functions, it would be y2 minus y1 over 3 minus 0, x2 minus x1. But we're using function notation here. So looking at the graph now, we need a value for f of 3. So here's 3, and the value is negative 1. We need 0. That value is 2. And 3 minus 0 is 3. So 1 minus 2 is negative 3, all over 3. So that value is negative 1. So looking here between 0 and 3, if we were to trace a little line, that line would have a slope of negative 1. So that's what that tells us. So looking on to number 2, we want the average rate of change from negative 1 to 2. So we set it up, f of 2 minus f of negative 1. Another way you might have learned it in algebra is this is the rise, f of 2 minus f of 1, and then 2 minus negative 1 would be the run. So we want to find 2, that would be up here. So at 2, we have a value of 2. And then negative 1 is down here, that has a value of negative 1. 2 minus negative 1 is 3, but that's the same on the top, so that has a slope of positive 1 between this point and this point. All right, so here for part 3, it asks we want two x values where the average rate, again slope, equals 0. Now with number 1, we had a negative slope, and looking at it, that means that line is falling as we read from left to right. For number 2, we had a positive slope, so as we read from left to right, it rises. So we want two x values where the average rate is 0. That means it doesn't rise or fall. That means it's perfectly horizontal. So two possible values that we could pick are these 2 points, x equals 0 and x equals 2. Those two would give us a perfectly horizontal line. And just for completion, another set of numbers would be these two down here, negative 1 and positive 3. That would be another horizontal line. And both are equally correct. No one is more right than the other. Okay. So moving on then, now we're given a function defined as an equation, and it tells us specifically a particle moves along a number line so that its position at any time is given by this function. So here's the position of that particle at time t. And so we want to find the average rate of change, that is how fast the position is moving from t equals 1 to t equals 3. So as before, we want s of 3 minus s of 1 all over 3 minus 1. So first we find s of 3, so that's 4 times 3 plus 6 sine of 3 pi over 2. That is the entire quantity s of 3. And then we have to subtract s of 1. So 4 times 1 minus 6 sine pi over 2 all over 3 minus 1. So 4 times 3 is 12. 6 sine of 3 pi over 2. Sine of 3 pi over 2, if you remember your unit circle, is negative 1. So times 6 is negative 6 minus 4. Sine of pi over 2 is positive 1 minus 6 all over 2. 12 cancels with the minus 6 and the minus 6, so we're left with negative 4 over 2. So the average rate of change is negative 2. Now, because this is given as a position, we have to answer it using a unit. And we don't know what the unit is measured in, so it's units per time. Again, we're not given units of distance or time. All right, so for the next one, we want to find the average rate of change from 0 to 5. So s of 5 minus s of 0 all over 5 minus 0. So 4 times 5 plus 6 times sine, extra parentheses there, 5 pi over 2 minus 4 times 0 minus 6 sine of 0 all over 5. So 4 times 5 is 20. Sine of 5 pi over 2, that's one full rotation with an extra pi over 2. So sine of 5 pi over 2 is equivalent to pi over 2 that we saw up in number 4, which is 1. So 20 plus 6 minus 4 times 0, that's 0. And sine of 0 is also 0. So for this, we have 26 over 5 units per time. Okay, looking on to the next one. Here we're given that a function is continuous, and at f of 2 it equals 3, and it has an average rate of change of negative 4 for all the values between negative 6 and 7. And so this problem is really working things backwards. Here we know what the average rate of change is, and now we want to find one of the missing values. So the way we approach this is we set it up as though we were finding the average rate of change. And we know that this problem is going to involve f of 7. But we need another point, and that's where this point up top comes from, f of 2. So we set this up. Now we know that this is all equal to negative 4. And so what we can do is we can fill in what f of 2 equals. Now f of 7 we don't know, but we're going to find it because that's the only unknown in this problem. So we multiply the 5 out. So we get negative 20, and then we add 3. So in this problem, f of 7 equals negative 17. We'll set up number 8 the exact same way. We'll have f of negative 6 minus f of 2 all over negative 6 minus 2. And that equals negative 4. So plugging in the value that we know that f of 2 is, we have f of negative 6 minus 3 all over negative 8 equals negative 4. So bring over the negative 8 by multiplying. F of negative 6 minus 3 equals 32. Add 3, so f of negative 6 equals 35. Okay. Now in the next example, we're looking at a circle, and it starts with a radius of 4 centimeters and begins to expand. Actually, that should read 3. That's a typo. And we want to find the average rates of change as the radius changes from 3 to 4 centimeters, 3 to 3.5, and then 3 to 3.1. Okay. So what we're doing is we're comparing the area of the circle to the radius as it grows. So we want the area at 4 minus the area at 3 all over 4 minus 3. So pi r squared is the formula for a circle. So that's 16 pi minus 9 pi over 1. And so we get 7 pi for 1, and that is our average rate of change. As it changed from 3 to 4 centimeters, it changed by 7 pi for the area. Now we want it from 3 to 3.5. So we want the area at 3.5 minus the area at 3 all over 3.5 minus 3. So we're going to square 3.5, and that is 12.25 pi minus 9 pi all over 0.5. So when we subtract that, we have 3.25 pi over 0.5, and that means we're going to double that, so we get 7.5 pi. So from 3 to 3.5 centimeters, it changed 7.5 was the rate. And then finally, we're going to look at it from 3 to 3.1. So the area at 3.1 minus the area at 3 all over 3.1 minus 3. And so when we square 3.1, we get 9.61 pi minus 9 pi all over 0.1. And so we have 0.61 pi over 0.1. And that's the same as multiplying by 0.1. And so we get 0.6.1 pi. And actually looking back, that was a mistake. Instead of dividing by 0.5, I multiplied by 2. When you multiply 0.25 by 2, you get 0.5. But 3 times 2 is not 7, it's 6. So this should be 6.5 pi. And that should be 6.1 pi. All right. Now, on the last one, so this generalizes the rule that we've been working with. So for any function, we want the formula for the average rate of change from x equals a to x equals b. So the average rate of change is going to be f of b minus f of a all over b minus a. All right. Thanks for watching. If you liked the video, please give it a thumbs up. If you want to see more videos like this, click the subscribe button. If you're a student and you like the video, share it with your classmates. If you're a teacher and you like it, share it with your colleagues. Share it with your students. If you want to support what we do here at the channel, go over to the Patreon link. If you have other questions, type them in the comments below. Thanks so much for watching. Remember, the only way, the best way to learn something is to do it.